You go to JavaScript.
Alright, it's recording, Panda, you're good.
You go to JavaScript,
Cool.
No.
Oh, I see.
I got one of those faces.
Sorry. Give me 1 second, I'll just open it back up.
Let's go over questions at technology.
I know why I use Windows, guys, by the way. And it's, just so you know, it's because of this camera controller. If anyone has any idea how to get like a Insta360 controller for like overhead mode and this stuff where it stabilizes like downward working on Linux, like please let me know. I struggled with it for a while.
Okay, you're the primary presenter now of this course. You've got everything now.
Can everyone hear me? Everyone's good? Like,
I do.
Just a little louder.
no, I mean online. Like, I just want to make sure. I assume that's yes. Can someone respond online? We have a couple people.
Yes, it's good. Jay say it's good.
Awesome. Thank you, guys. So, first off, actually, I'll just mention my disclaimer real quick. So, you know, everything that I show you here, I'm not telling you to go out and hack, you know, a bunch of stuff and maybe cause harm in the real world. You know, there are plenty of things that you can take this knowledge and go hack that don't cause harm. There's actually a lot of opportunities to make the world a safer place by hacking things and, you know, showing the vulnerabilities that are out there. You know, there's more and more IoT devices, you know, car charging networks, etc. You know, just infrastructure going out into the world every day, and you know, not all of it's safe all the time. So the more people doing research, the better. But like I said, don't cause harm, or if you do, I didn't tell you to. A little bit about me. I go by Panda. I work for RedSeer Security. I'm currently the Director of Defensive Security and Strategy. I do a little bit of both, and I think that's one of the reasons I like my company so much. It's full of red teamers. I guess I'll mention a couple things. So like, I am very curious. I'm not, I would say, any one thing by trade. I'm a hacker first and foremost, you know, a coder second. You know, when I'm working through stuff, you know, there's definitely knowledge gaps that I've had throughout the years. I never went to like a formal college or anything. It's all self-taught and, you know, just patched together through things. So like every time I get a course, you know, at DEF CON or Black Hat, you know, like I try to soak up, you know, whatever knowledge I can get. Yeah, I'm learning with everyone else. So, you know, if you learn something cool, share it, because, I think this stuff is awesome. And this is literally me sharing something I learned recently. The PiFex, I didn't really know about until HackSpaceCon recently, and I don't know if I have my pirate over there, but I have another device, this one here. Let's see if I can show this on screen for you guys. Yeah. So this device here is the PiFex. This is what we're talking about today. It's kind of hard to see, but this one here. And that device I learned about recently in a training class at HackSpaceCon. I was working with some of the Praetorian folk, awesome team, and basically, like previously, I would attack some of these same problems using like a bus pirate, which is a pretty common tool, or just programmers if I had something direct for a chip that I was working with. And to be honest, like most of the hacking that I've done on this stuff has been DEF CON badges. When I'm doing something like late at night on a badge, and that's how honestly a lot of my knowledge has kind of come to fruition. Where I'm learning from seeing the design decisions that other people are making. Guess this. Working with the, I don't know why it won't let me do the one display, but whatever. So another thing about me, I volunteer at B-Sides JAX, I volunteer at B-Sides Las Vegas. I already mentioned DEF CON and Black Hat. I'm excited for Black Hat this year. I'm going to some training from BC Security, and then I'm staffing B-Sides Las Vegas, and then I'm going to play the Tele-Challenge at DEF CON, so I'll be freaking most of DEF CON. So if anyone's out there and, wants to hang out or, whatever, if it's DEF CON, I'll probably be holed up in the suite, and you're welcome to come hang out for a little bit if what we're doing is not too intense. But the rest of the week, I'm going to be there from, I think, the 1st to the 11th, so, please hit me up. It's going to be a good time. DEF CON's amazing. I learn a ton every year. It inspires me. This stuff here, so this is the B-Sides JAX badge, one of the ones that I've made over the years. I just made the Hack RedCon badge for our con up in Louisville as well. And then this is me at DEF CON, dressed like a panda, with a friend making a PSTN call to one of his friends, I think in the Northeast, or his mom or something.
Did you make the costume or you edited it out?
No, that was Lacey. I think she had fursuits.org or something. But yeah, like it's kind of a joke, but kind of not. Like this logo here is like DEF CON furs, and basically, like there's so many furries that are involved in technology, and just weren't open about it outside of their little one-line persona. So like at DEF CON, a bunch of people used to get together in the bar and hang out, after they're doing their talks on the main stage or whatever else, and running the con, and that kind of turned into why are we afraid to be furry? Like DEF CON is like a group of misfits. Why are we trying to be professional? It doesn't make any sense. So we started DEF CON Furs, which started as a chat and like basically a bar meetup. It evolved in the QueerCon pool party thing, and now it's a full event where we have a suite throughout the con. We have tracks. We do a bunch of stuff. We used to joke like. Someday we're going to have a fursuit parade through closing ceremonies at DEF CON. That's a scheduled event for the past couple of years, so it actually happened. It's really cool to see. So, anyway. I also run Comms for All and then JAX Mesh. So if you're in the area, I'm really into the mesh casting. Yeah.
Oh man, I love it.
So come to JAX Mesh. It's jaxmesh.com. And we have a Discord, and we're doing meets every month. We're trying to create a net where we'll, hopefully go over all over town eventually. But right now it's very small. We need more people on the mesh. So.
When's your meeting? At
So
JAX
it's the first Monday of every month. So. Talk about. What did you say? Sorry.
Oh, I thought it was WASP. Isn't it WASP the first Monday of the month? Sorry.
Maybe. I mean,
It just seemed like.
I go sometimes.
Okay.
But I've been going to JAX Mesh. I just picked an arbitrary day. If we want to change it in the future, definitely can. I haven't been to a WASP meeting in a little bit. Are they still doing Secure Ideas, or where do they do it now?
Where?
Do you know where OWASP moved? Is it still Secure Ideas?
No, it's. I
It's
think
on a training center next to,
it's not far from here.
across the street right here. You
Yeah.
know where the Wounded Warrior
Star
building
View
is at?
Oh, AC
Starry, yeah,
whatever?
Starry.
Yeah, Star.
Okay, cool.
Star Learning Center is
Yeah, if I
there.
overlap, I'm definitely.
So it was kind of a random thought.
No, that's good. Thank you. But yeah. Anyway, come check us out, or if it overlaps with OWASP, then that's a problem. Also, please let me know that feedback, and for anyone else, So anyway, to get started with this stuff, why would you want a hardware hack? I just want to talk through that, and what can you hack? What is around you that you can hack without breaking walls, without doing, any kind of crazy stuff that's going to get you in trouble. And, for me, a lot of times it started with broken hardware. I had that image on my first slide, it's okay to take things apart. But that was like totally me as a kid. I would take stuff apart and my parents wouldn't be happy with me. And most of the time I would learn something, not all the time. Sometimes I would destroy something unmeaningfully. But a lot of times old broken hardware has been, okay, well now it's okay to take that thing apart. It doesn't work anymore. It's going to go in the trash. instead of going in the trash, it goes in a box, and you know, maybe someday I mess with it, maybe someday I don't, and I throw it in the trash. You know, there's no harm, no foul. You know, so old broken hardware is a great way to find targets. Conference badges. So I have a picture, a couple of badges up here. So these are mostly DEF CON badges, but there's a variety there. And honestly, like I was telling you before, that has been a way that I have learned a lot throughout the years, is just going to conferences, seeing what chips people are playing with at that time, seeing what design choices they're making, what features they're implementing in other badges, how difficult those features are to implement. Like, for instance, the original DEF CON FIRS badge, I made the original, but the original like PCB one was a year after that, stainless steel one we did. It was the electronic badge basically had like a loop, and seeing how that was designed into our badge and learning from that and how simple that capacitive touch, you know, was like a cool thing, you know, but I never would have thought of doing that over a normal switch until I saw it in practice. So anyway, that kind of stuff can inspire you, and also, you know, those badges are just fun to hack a lot of times, and sometimes have challenges built onto them that, you know, you learn a lot from. So definitely recommend that. There's also training boards. I was mentioning HackSpaceCon. This is the class that I went to. I have one of their challenge boards here today. I'm going to be showing you something from that. And basically, you know, there's boards that are just wholly designed to teach you the fundamentals of hardware hacking, and, you know, sometimes have fun challenges built onto them too. You know, you can get sometimes as part of a training class, other times, you know, maybe it's a kit that you buy and you walk through the steps at home, but there's a ton of resources out there. There's also stuff like, I don't know if anybody's seen Matt Brown's YouTube. He has an awesome hardware hacking YouTube, and yeah, I love his stuff. And if you're on his Discord, he has a security research team that you can go. It's really open to anyone, all skill levels. And the cool thing about that is the group decides on IoT devices to buy, and basically hack together. And then they have a collab, you know, where we're putting together a formal report of all the vulnerabilities in the device. Right now, the device that I'm playing with, it's this good top here. It's one of the devices that's up here. That's part of his security research team project. And it's a blast. I definitely recommend, if you're into this stuff, you know, it's a good way to just have fun on weekends, figure out, you know, kind of stuff you don't know. Like this device has a new Realtek chip that no one's leaked the data sheet for yet. So we're kind of messing with it. It's a 2.5 gigabit switch, so it's newer stuff, and it seems fun. Another thing, so like benefits, you know, of hacking things. There are a lot of things to hack and get paid for. I listed HackerOne there, Logitech, Ring always has like hardware on there for bug bounty. There's a lot of the companies that produce hardware and really want it tested. So, you know, if you get into this stuff, if you enjoy it, you know, you don't have to go to the dark side and, you know, get in trouble. There's ways to make it work for your benefit. And there's also things like at DEF CON, the IoT Village, and then sometimes opponent-owned events and other events where you can hack on live hardware and either get, you know, a reward. If you, for bounty, a lot of times they'll give you like your own piece of that hardware. Or, you know, some kind of cash prize or whatever if, you know, you find a certain vulnerability. You know, but there's a lot of events where those companies are trying to reach out and work with hackers and make their products better. So, like I said, if you like this stuff, definitely check it out. So, I put untrusted cheap here. So it's like, this is a very Chinesium, you know, switch.
What did you say?
Chinesium, it's straight off Alibaba. It's a good top.
Sometimes the good target can be the one where the manufacturer was not proud enough to put their name on it. Those people will not come after you.
Yeah,
So,
anonymous bullets. Okay.
so yeah, like this switch is, I think, like 10 different brand names on
For
Alibaba
example,
right
he has
now.
a logic analyzer there that is named Logic Analog.
Exactly.
You don't know who made that.
Exactly. So sometimes, like those can be good targets. If it's a cheap piece of electronics you don't care about, or if you don't trust it, maybe you want to dig in and see if it's doing something it shouldn't be, or if you think it, end up finding it's really cool and it's awesome, it just works the way it should. So I mentioned bug bounty. Let's see. So goals. So I mentioned some targets that you can figure out. There's also things like if you're in a home automation, definitely try some home automation hacking. There's good projects like ESP Home is a really good one where they make open source firmware for some of these home automation devices. You can load stuff on that way. So I know a lot of people, that was like their gateway drug into this stuff too. So if you're into it, definitely check out ESP Home. Troubleshooting devices, sometimes the device doesn't work the way you expect, and you want to just figure out why it's not working the way it shouldn't. Other goal I mentioned before a little bit, trust and verify that the device is doing what it's supposed to be doing. There's no real way to know without digging in some way. So we look at like they add USB cables and stuff, like there's a lot of devices out there that we're plugging into our computers, that who knows if we should trust them. So maybe you want to expand features of a device. A good example that I have right now that I'll do when I have time is my truck, it has a 10-minute timer for the remote start, and I have a puppy, and I live in Florida, and that sucks. That makes some really stressful checkout line situations. So I want to figure out how to expand that and know for sure, from a mile or two away, that my truck is still running. So I have all the pieces. I have LoRa and a bunch of cool MCUs to work with. So that's a fun project. But there's plenty of times that something almost works the way that you want it to. It's almost perfect except for that one thing. What if you can make it better? Maybe you want to build your own. This is definitely the case with me and conference badges. I definitely like seeing what other people do. That also expands beyond conference badges. I think there's so much open source hardware out there now where you can buy a module and integrate that module into your circuit and learn from that, but then literally go look up the data sheet and take that schematic and integrate it into a board with the other stuff. I am not an electrical engineer, as I mentioned. A lot of my friends are jealous. But at the same time, you don't have to be now. It's a game of Legos a lot of times. You make your block diagram.
And if you have a really weird problem, don't worry. Some electrical engineer will absolutely help you figure that out. Be like, yeah, you've got insinuation. You need to just fix that real quick.
Yeah, exactly.
Oh, okay, cool. But most of the time, it's like, nope. I just put the pieces here, draw the lines, we're done.
Yeah, what features do I need, and then you build that block diagram based on that.
Yeah.
But yeah, it's not as crazy as it sounds when you break it down.
The amount of ICs that we have, they just make it so you don't even need to know a lot of the circuits anymore.
Yeah. And then the last goal here, just because I'm a security guy, is exploit. So, a lot of times there isn't much security when you're on the board. There's a joke that, the S in IoT security is, there's a S in, sorry.
The S in AI or?
The S in, whatever. Yeah, the S in IoT stands for security. Exactly. So a lot of times you're dealing with really basic problems that could have been overcome if someone just put the effort into it. Maybe the team didn't have the resources and they were just trying to get a product out the door quickly and maybe iterate down the line or whatever. Whatever the excuse is, sometimes it's okay if it's a digital microscope, sometimes it's not okay if it's a boat, So you want to help remediate those issues and, honestly help that is a goal, thing of helping those companies understand those issues enough that they can make that investment to fix them. So I talk about some tools. The dental floss is not a joke. I just used that to get the heat sink off the switch here, which was on there like crazy. This here is a soldering iron. I'm sure a lot of you guys are familiar, but this is a pine sol specifically. I really like them. I have one here in my to-go kit. I have a big weller station at home. The microscope is super useful. A lot of times when you're trying to figure out what's going on the board, you know, you can only see so much when it's tiny. So if you can't read the writing on this, you know, getting to that next step is hard. Once you can read the writing, it becomes a lot easier. And there's also definitely big magnifiers. I get a big magnifier on my desk. It's super helpful. But a microscope for smaller MCUs is really, really useful, and I definitely recommend it to anyone getting into this stuff. Multimeter. Multimeter is great. You know, like there's a ton of stuff you can do with the multimeter, but testing, you know, continuity, testing voltage, you know, etc. It's just all around awesome tool. Make sure you get a real RMS multimeter. If you buy super cheap ones, they're not going to be, but any of the like standard stuff is going to be.
Which one is that one that you have?
This is like a Klein Tools one. This is actually from that training that I did. It came with some tools.
Okay.
And it's just like, I have a stack of multimeters.
I wish I could buy a scope.
At home, yeah, scopes are nice. The Siglent, I like the Siglent scopes.
Yeah, Signet's really good.
Yeah, I really want one. I don't have a scope right now. I need one.
I just got one of those like cheap pocket ones from AliExpress with like the built-in LCD, but it's not super fast.
Yeah, I have an old school scope at my dad's place that I used to use for a bunch of stuff, but I need to see if it's even still in his basement. I don't know if he cleared it out or not. But I don't have anything modern. I need, that's like my next to buy when I have a little more money. So anyway, ESD. So that's like an ESD mat. Electrostatic discharge isn't such a big deal here in Florida, but if you're other places, take it really seriously. I used to repair a lot of like laptops and tablets and all kinds of stuff like that, and yeah, your failure rate went up a ton if you didn't actually use ESD protection. So here in Florida, like I said, not as big of a deal because of the humidity, but anytime it's drier, you know, seasonally or whatever, it does definitely can be a big issue. You don't want to fry something that you're working on because you weren't ESD protected. So this is a chip clip. So this is like, say you have a memory chip that you want to read, you want to dump the memory chip, and we're actually going to show that in a little bit. You can clip directly onto the chip. It's just one of the ways of doing it. I have one right here. If you guys want to check it out after the presentation. This here is my logic analyzer that I have. It is definitely a generic product as well, but it works well. They're super cheap. I think this one was like $15.
Yeah, they're like 10 to 15 bucks.
Yeah.
But like, and I made that joke because it's like it's a quality thing, and like a lot of those are knockoffs of the Saelae.
Yep, exactly.
And that's why they don't put their name on it. It's because it's pretty much a clone.
Yeah. We just found a need to actually get a fancier logic analyzer, which is the switch. It operates beyond the scope of that one.
And that's actually a recommendation I'm going to make here. Buy what you need and then outgrow it.
Yes.
Like logic analyzers, they can go from this little like $10 price range up to several thousand. Buy
Yeah.
the one that you need. Buy the $10 one and wait until you're like, okay, I've hit my limit with it.
Or I've shown on the other side, like targets. If you have a target, you know, think what you need for that target. Work
Yeah,
it like
that
a
too.
project, you know, and then you'll end up with a really cool kit, but it's not stuff you don't use, you know, because you just didn't put the time in to figure out how to use it. You bought it for the project, you know, you figured it out for the project, and then it's a new, you know, tool, it's a new skill, you know. Every time you do a project, you should be learning that stuff. So this here is a PC Byte. These, I have them up here for demo, but basically these help you without soldering on to some of these tiny pins on the MCUs. It allows you to interface and, you know, jack into some stuff on the board, and, you know, really quickly change where you're connected. This is the PiFex that I was showing before. It's from VoidStar Security, and I definitely thank the Praetorian team for introducing me to it, because I think reverse engineering with Raspberry Pi is really cool. So, why Linux and Raspberry Pi for debugging? So, one, it's ARM. So sharing the architecture, you can use the same tools if you need to. It's a full Linux distro, so you can load whatever you need to on that system. And also, if you have some dumb Windows system, you still have your Linux system, for hardware hacking with you. So natively, so it has access over network, which is SSH or USB. You can run it headless. The PiFex is really cool because it even has this little display that shows you the adapter IPs after it boots up. It's pretty nice. So by default, there's access to your SPI, I2C, and PWM with your GPIO on the Raspberry Pi. The PiFex really just adds the ability to change, so you could do like sub 3.3 volt communication. Some chips, operate lower than that 3.3. So you can basically, there's a switch here that you switch it and you feed whatever voltage into it, and that'll allow you to communicate that way. It's really nice.
Does that let you go north of 3.32? Because some things do use 5.
I think it does.
Okay.
Yeah.
It's just like a VC.
I haven't had that project yet, but I'm pretty sure it does. It's dual bidirectional level shifters.
Okay.
And then the logic analyzer connection on the top of the PiFex, you've got this little logic analyzer connection. It just makes it a lot easier to do logic analyzer stuff with your stuff you're working with directly. On Linux, there's a ton of cool tool sets to work around hardware hacking. For the purposes of this demo, I'm going to cover OpenOCD, Screen, and flashrom. I'm going to show you guys those. So, and this is like a pinout. If you guys aren't familiar with what a pinout is, it's just a breakdown of this connection. It's showing you what the pinout is. This is a default Raspberry Pi 4, and then the PiFex is an additional thing. It's got all of its GPIO up here, and it's all labeled for hardware hacking. It's pretty much ready to go. So, and then process. Pretty simple. When you break it down, you want to disassemble your physical device so you can gain access to the board. A lot of times when you do that, stuff is noticeable off the bat. So you might see what is clearly a debugging interface, and it might be labeled as such. You might see test points on the board. You can look at the chip itself and figure out what type of chip it is. Look up the data sheet, for that chip. So that's identifying the chips of interest and the OSINT data sheets. We'll go into that in a little bit. And then you want to look for interfaces. So like whether that's sniffing, there's a protocol called SPI that if a chip is talking to a memory chip, it's going to speak that way. You can sniff that out. You can connect directly to UART, which is basically serial. There's a bunch of different interfaces. You might get SWD, JTAG, et cetera on these. So think about a circuit. If we were talking about the block diagram before, it's all broken up like Lego pieces, and all those pieces have to speak to each other. So if there's a sensor somewhere, that's speaking back to the main chip somehow. So you can sniff that and figure out what's going on there. Sometimes you can gain access to data that you shouldn't be able to gain access to, if you were just not, disassembling and connecting to it. So you want to monitor, interesting. You want to monitor, I hope it reconnects. Yeah, it is. You want to monitor during normal operations. So say you find like a UART, serial interface or, single wire debug or something. You want to monitor that stuff while you're using the device and try to see what normal patterns are for the booting of the device, the functioning of the device, what's going on. There's some stuff later where like every 10 seconds something is being written to like a memory chip. A flag is being wrote to that chip. So like there's normally just like on Linux, there's processes that run regularly and things that happen regularly. So you want to try to figure that You can dump or back up firmware if you get into one of these debug interfaces. You can modify firmware. This is kind of beyond the scope of this class because I want to show you the hands-on stuff and connecting to the devices and test beyond there. So I have some OSINT examples here, and I'll see about pulling up the pages in a sec. But it's basically a ring device. The first one I wanted to show you on the bottom of the device, you have this FCC ID here. You can actually look that up on the FCC's website and gain a whole bunch of information about the device. It's got a user manual of the device, it's got a bunch of testing. This device is actually kind of cool because it's got Z-Wave, it's got cellular, and it's got Wi-Fi. So it has a ton of stuff going on. But anyway, that's a really, really good way to check stuff out. Another thing too is if you read the MCU, if you read the text off it with a microscope or just with your eyes or whatever, and you look that up, you can find a data sheet of that. This is a system on chip, so like ESP32S3, but you can literally look at the text on it, look that up, and you get this data sheet. Let me see if I can put this up. So these are the operating frequencies of the ring device that I was showing. This is the Z-Wave operating the 900 megahertz bands, and then the Wi-Fi and cellular the others. Oh yeah, and Bluetooth, yeah. And how my Wi-Fi there. So you can see the kind of stuff that we get here. I'm not going to open any of these, just my laptop's being a little slow. But there's a user's manual, there's actual test report, there's documentation of their test setup for testing all the RF on the device. Wow. And when you're a maker and you don't have like the budget to go through this testing process, the FCC, you can get around all that by using like a system on chip or something someone else designed and tested with the FCC. But it's that use case for manufacturing stuff. So the other device, that badge that I showed, that's an open source furry badge. It's for Eurofurry, which isn't even a HackerCon, it's just a FurCon. But some like Chaos Computer Club furries decided to make it and have some fun. But that's open source, you can check that out actually. But for documentation instead of that, I want to show you guys the data sheet. And it shows the different models of system on chip. A system on chip is basically a whole integrated circuit on one tiny little chip with all the Wi-Fi and everything built in. Antenna optional. Talks about module design, RF characteristics. You're going to have pictures of the chip itself with the pinouts. You're going to have documentation for how to interact with the single wire debug, the block diagram, everything. Like I don't know how long this document is with ECL.
52 pages.
Exactly.
52 on this one.
When stuff is documented, or when I should say, all stuff is documented this well in this world, the electronics world, but some documentation isn't public unless you're buying their ICs in large quantity, like this Realtek. This Realtek one, they have a GitHub that they leak it, but there's not a bunch of the current ones. So anyway, let's see. So, what was that? What did you say, Travis? I'm sorry.
52 on this one.
Oh, 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52. 52
do it?
You said something a second ago. No.
Can't remember what I said.
That's not going back. So I'll show you the UART in the unknown baud rate demo in a second. We're going to use the logic analyzer for that. I'm going to switch to the camera, and then I'll bring my PowerShell session over so you can see that. I'll bring that up on the screen. Let's see. Close this. While I pull this up, it's just going to take me a second. Does anyone else have any questions or any comments?
You mentioned JTAG and
Single wire debug.
single wire debug.
I'll show you single wire debug today. Single wire debug is kind of the new go-to with all these ARM chips.
Yeah, it's like the ARM equivalent of a JTAG.
It's just got less connections.
So what is JTAG?
So
JTAG is Joint Test Action Group,
Yep.
and it's a hardware interface that creates a uniform pinout for a testing interface. And what that means exactly depends on each chip. But it was designed, and it wasn't really for hardware hacking or debugging really. It was actually for testing, like it said, because we eventually invented these chips that are called ball grid array. So he was showing those chips there where it's got the little leads on the outside of it. This is where there's just a bunch of dots on the bottom of the chip, and then there's a bunch of dots on the board, and then we solder that with a machine. Cool, but how do you QA that? You can't get a probe to it, you can't visually inspect it, you have to have some mechanism that would let you test that through other means. And that's where JTAG comes in and say, I can literally say, turn this pin on, and I can read other pins from it just using this interface. Which would allow me to detect, say, a solder short. If I put all pins to low and I turn one pin high and then one other pin is reading high, something's wrong. So you can do that. But a lot of times they've also included a debugging interface into it too that would allow you to do hardware debugging. And he'll go over that later because he said he was going to mention OpenOCD, which is the tooling that you'd use for that. But it'll normally let you read your flash chips. You can identify chips that are connected and adjacent to your chip. You can also daisy chain these together, so you can actually debug multiple things that are connected that way. You can use it to dump flash. You can also use it to do a hard halt on the hardware, which is kind of cool. And then you can actually connect GDB directly to the piece of hardware and start debugging on the hardware. So if you have an ARM-based device, I could sit there with my computer and literally debug the firmware in real time that's running on it and look at the registers and everything on the CPU on the device. Yeah, it's pretty cool. You can also use it for a little bit of firmware hacking because you got GDB. You can actually write memory. So if you wanted to modify the firmware while it's running on the device, you could halt it, make a modification, then resume execution. And that actually would not survive a reboot. So kind of neat. But SWD is the shorter version of that, where you just need pretty much there's there's a data in and a data out pin and ground, and that's not it.
Self-blocking.
Yeah. It's pretty cool. I did a talk on this with the Flipper Zero, and it was kind of cool because the Flipper Zero had one tool where it was just
where did you
plug the pins into anything and we'll figure it out.
where did you do your talk?
I did that one for work. I work at Computer Ideas, and I've done 2 talks on hardware hacking with the Flipper Zero. And they're up on YouTube if you check out the company's channel. But there's the first one I went over using it as a UART bridge, USB to UART bridge. And I gave you one of those SPI bridge. Yeah, so you can use it as an SPI flash chip reader, writer, dumper, verifier. And then I used it as an AVR programmer to program the Atmel microcontrollers, and you can also use it to dump them. And then the second presentation, I went into the SWD and JTAG. So, you actually use yours with the Logic too?
Yeah.
I was not able to get that working with my cheap one in Linux for some reason. Like it actually, like I think they.
It's one of the
recognized-
reasons I'm using Windows. It
Yeah.
works a lot better. I don't
was
know
using
why.
SigRock.
Yeah. Alright, so what I'm going to show you guys, I have this hooked up here to this switch. This is the switchboard. And basically there's this is already on the switchboard without these headers, there was a spot to solder headers. So just the empty holes. And I just took, some headers little headers, DuPont, and soldered them to those holes, and then you can connect directly, with these. So in this example, basically, like, the thing was already there to connect to. You just needed to add a tiny thing to be able to do that.
And they look like an all USB header.
All USB header? Old USB?
The very old USB.
No, it's a little bit different.
No, it looks like just four.
Yeah,
It's like a
four
4x1 row of pin headers.
Yeah.
Most of
They
the
look
time.
like, just like the ones on this,
You have to sign.
all DuPont headers. So all these little pins, that's what it is, it's just four of
Yeah,
those.
yeah.
Maybe it's the same, I don't know.
They're very, very old, like 386 computers when they first came out USB. It was just a 4-pin connector.
Oh yeah, you're talking
To
about
plug
the
into the
motherboard for the
motherboard?
jumper
Yes.
connector.
Yeah, for the
It's that same
motherboard.
connector.
Yeah, that makes sense. Alright, let's see. So,
Yeah, no worries. We got there.
I'll pull up Logic.
There were 386
Um,
computers?
And on here, so I want stuff to happen, so I'm gonna unplug the board and plug it back in so we get power into it.
Weird stuff is happening.
Yeah, some weird stuff's happening down there.
So you what channel?
So we can go ahead and stop it. And I'm gonna zoom out. If you ever can't find stuff on here,
Just really zoom.
yeah, just really zoom out and go back.
Because so what you're actually seeing here is like it samples whether data is high or low,
Kill this actually.
and it just kind of shows it over a scale of time that is usually in the nanoseconds.
Yeah.
And as such, like he just ran this for a few seconds, but that's millions of samples, so the horizontal length on that gets really long.
What's
So-
the sample rate on
This right now I think is running at 16. It went up to 20 something on these. But yeah. But so anyway, these analyzers, you can add these. You can look at the raw data. Like we can zoom in here, and you start to see stuff. And in this data, yeah. So one of the things here is the width. That's close to a common like baud rate. So if you guys have worked with baud rates, with PuTTY or anything you've connected with over the years, serial, it's close to 5700. So that kind of identifies, if you don't know the baud rate, you can determine it kind of from what you see here.
Yeah,
And-
my shortcut is take that number, divide it by 1200 and 4.
Yeah. And then analyzers, so there's a bunch of different stuff that you can analyze if you're sniffing. In this case, we know it's asynchronous serial, and I have 57600. So let's just save it like that, and we can go in here. This is, let's see. Yeah,
This is
that's-
so much better than SigRock.
I know. So these are the ASCII characters that it was reading out. So you config, area, so this is literally the console that it read out to us during that boot.
Cool.
But there's in data, and then this is a better, kind of
Revo.
simpler view. Now say we've discovered this thing, so we've gotten here, which is super cool. Now we can connect to it. So
The reason for the bothering is that your doesn't have a clock signal, so both sides just gonna have to run at the same speed, otherwise it's gibberish. Probably with power cycle.
Yep, exactly. So power cycle, and we should see stuff.
Oh, if you left the logic analyzer running, it might still have the comm device.
Yeah, actually, you're probably right. That's like no, that wouldn't matter because it's on the Pi. It's coming off of
Oh,
here.
okay.
Yeah, that's what's badass about it, actually. Huh. So let me. There. This is not up to fall.
Looks like you're in the Pi dot screen.
Yeah, it's just turning. Oh, it's S. I forgot the S. Like that makes sense.
Oh, there's a /dev/serial/PiID. It's also pretty cool to use.
Cool. So this is the switch booting. And all I really know about it so far, and we're figuring this out together.
Restore IP. I'll bet you it wants to talk to a TFTP server there.
Yeah, probably. That would make sense. There's a web interface, and just kind of default web interface, and if you hit this, there's a key is wrong. Also, when you try to reset some stuff in the web interface, we see that too. There's a lot of times if you're trying to, remember I was saying use it in normal operation. One thing you could do here is connect to the web interface and see what you see on the console itself.
Yeah, because it usually outputs debug messages.
It might give you hints, about where else you can dig and how the system's working underneath. Oh, it's connecting to AWS. Because it's debug stuff. A lot of times these guys aren't thinking someone else is gonna look at this. They're thinking I need to troubleshoot my crap before it goes out the door to a customer, make sure it works right. So anyway, this is the one for UART unknown baud rate. See if I can move this thing down. Slide. Oh, freaking out. And I'll just show you there. So to exit out of the screen, if you guys don't know, it's Control A, K, and then you hit yes for kill, or Control A and Control D to detach, and Screen-R to reattach. Screen's similar to TMUX, it's on a lot more systems. If you haven't used it, you can split the console a bunch of different ways and let background processes run in a pretty nice way. So
I usually recommend the kill instead of the detach.
well, it depends what you're doing. Sometimes you want it to keep running, so yeah, exactly. But yeah, if you're not using it anymore, definitely kill it. And then the next one I'm going to show you is dumping and analyzing SPI flash. So give me a second. Show you that. I appreciate you guys being patient with the screen stuff. It's just a little funky. Let's see. I blame Windows. You should.
Always.
It's always Windows' fault. I do have my Kali laptop. I think I do anyway. And that was my plan, was to use that, but this camera thing was the biggest piece.
It is a pretty cool camera though.
I love it for overhead stuff. This is what I've used for the besides JAX badge videos and a couple of the other stuff I've done. It also just works really good day to day. It's been a great camera over the years. Let's see. So I gotta hook this up for SPI. So in this case, we're not that far on this board. I showed you guys the demo for that. That's this live switch that we're hacking right now on Matt Brown's Discord. So if you guys want to join, you can order one on Amazon or AliExpress. And there's a collab that you can join, and we're literally going through and figuring it all out right now. So like anyone is welcome to that, skill level aside. Doesn't cost any money. You join the Discord, buy the thing, and hack it. This was like $30, so it's not expensive. And if for reference, a PiFex, I think they're like $75 right now if you want to hack. So they're not super expensive either. You need a Pi 4 is the recommended one right now for them.
The smaller board's a little bit harder to see because it's kind of partially obscured by your.
Yeah. So this is the PiFex here. This board.
That's the hat that's sitting on top of the Raspberry
The
Pi.
hat is on top, yeah. Not this little board here. This is just connects to the logic analyzer. This whole piece here. It takes time for my finger to show up. But this whole piece here is by VoidStar Security. That's the PiFex hat, and that works with their basically PiFex build of Raspbian. That is all open source and on GitHub.
And it looks like there's a little monochrome LCD on top.
That little display shows the network interfaces. So there's a couple different ways to connect to this board. If you throw it on the network, it'll show DHCP, and you can just connect to it that way. It'll show the ETH0 interface to the DHCP that it pulled. In my case, I'm using the HIPAA address that it's getting to connect to it. I just set a local adapter. If you're on Linux and interacting with this, it's actually really nice because it loads like a Nokia phone network driver. The Nokia nothing. But it's nice because you can just configure that adapter and you don't actually have to have another USB network adapter if your system doesn't have one, it just USB cable to it. But you have those options, it's really flexible. And it doesn't, one of the nice things about being able to just toss it on the network is it can be at your workbench, not at your PC. And you can still do hardware hacking back and forth, so my workbench, like my setup's like about this table, area for hardware hacking stuff, but then over there is like my desk and stuff. So, it's nice to be able to hook all this up to the Linux computer that I have there, and then just connect it across the network, or hook this directly up on the network and connect to it that way, because it's just SSH, and it also allows Telnet as well, so you can Telnet directly into it too. So the SPI flash, finish hooking this up. So this board, chase is hard. The SPI flash. So the on this board here is Praetorian's little challenge board that they made for the class I was doing, and I was going to use the clip over here, but it's a little unreliable. So for class, I just went to hook it up directly. The pins are all labeled here for what they are. I'm not going to go over it too much right now, just for the sake of time.
Is that effectively kind of like an Arduino, but with more breakout stuff?
It's a Raspberry Pi base.
Okay.
Yeah.
I was looking at the head handlers on the side.
You can check it out more later if you want.
Sure.
Let's see.
This is like test clips are amazing.
Yeah. I think that's right. Let's see if we can talk Ray off you. Ray. Oh, not you, my other Ray. Huh? Ray is in the he's on mute. So,
should be able to just do Control L and it should clear.
Control O.
L is in Larry.
O L. Yeah, perfect. So let me double check my connections. Oh, I know. All right, so it's not working because we didn't do the reset. So this is a good lesson. So
Can you go and
basically-
share the screen with there's people online
Yeah,
that
yeah.
might want to see it.
Are you able to see that perfectly?
No, yeah, but there's people online that they're
Yeah,
just
yeah.
looking at a terminal.
That's perfect. So basically, this board, as I was saying before, there's a process that writes to flash every 10 seconds. So essentially, we're competing right now with the main microprocessor, this chip here. One communicating with that chip. So we have to find a way to stop that MCU from talking. In some cases, that could be desoldering the flash from the board and reading it without it being connected to any chip. In this case, we can hit the reset pins basically for that MCU and keep it in a state where it's not communicating. So that's the way that we're going to go about it here. So to do that, real quick.
It's like a hardwired jump, huh?
Uh-huh. Yeah, in this case, but it could also be us hitting 2 pins on the MCU directly. It's just broken out on this one to make it a little easier. So, let's go back to PowerShell.
And
What's up? Yeah, perfect. No, maybe not. Let me try. Try this.
Tell me about it.
There we go.
Put that miso mosey backwards. Same right now,
Which
but
one?
the miso mosey.
Input output.
So we read flash there from our flash chip. And then let's see, let me make sure I did it. So on this one, it's a challenge board, so it has flags, sweet memories at the top, and sniffing SPI for some of the challenge stuff we were doing.
Assume the second flag was for sniffing it and the main board was just reading it.
So yeah, there was sniffing SPI where we got the first flag, and then later on we got to the flash. So that's another level. I'm gonna show a single wire debug real quick. So single wire debug, like we were talking about before, is very similar to JTAG. And it's a debug interface for these. Oh. And just so you know, Christian, this is my last demo.
360 is such a cool camera.
I really like it, and it's good for calls and stuff, just normal stuff too. So, let's see. That actually did really well though. We're using OpenOCD here.
So it's an STM32 chip then.
That's right, yeah. I don't remember.
So the F switches are specifying your config files. He has to specify one of them to explain his programmer, which is that Raspberry Pi one.
Yeah.
And the second one to explain what the target is.
And if you need to remap pins, you do it. First one in class, we had to remap the pin. So that's why it's like dash SWD. So yeah. And then, let's see.
Yeah, it just opens ports for you.
No, that's fine. I just gotta go the other. I'm gonna do it this way. Yeah, so we're connected to the on-chip debugger. So that's the other session that we started. And we can try halt and see if that works. It did not, so let's see. Make sure my connection's right. I would say that like 99% of the time I run into an issue, it's like me connecting something wrong because I'm just
Don't
like.
feel bad about that. It's amazing how many times too you're like it's connected right, but yeah, your jumper is just a little sloppy and
Yes,
not making a good
exactly. Like
contact,
that
so
chip.
you're getting like an intermittent connection.
That chip debugger. Oh. Let's see, it's right. Try repowering it.
We need to restart it.
Yeah. Processor connected. Got it. It didn't read it before though.
Can I ask you a question?
So we halted it.
There we go.
Panda?
Yeah. What's up?
Yeah, I little bit confused. Where you have your router or was some other network?
He's hacking that little like PCB that's there.
PC.
There's a microcontroller on it that's running some code, the firmware on it. And he is directly connected to it, and he is currently using this OpenOCD to control the onboard debugger that's built into the chip to halt the chip. And he's getting ready to use it to do a dump of the firmware off of the device by using that. It's SWD, it's a debugging interface that's built into the chip.
Okay, so in real life, how do you have other computer? Like that we use the board, I confused. In real life, how do you have?
So like this is it's very specific to device, but like so He's got his computer, that's gonna be his machine that he's going to attack stuff, and as we can see, he's actually already got the firmware off of it.
Yeah. So.
Wow.
That's the,
JTAG is
on-chip
amazing.
firmware?
Huh?
That's the on-chip firmware?
That's the on-chip firmware. So this is the main MCU that we dumped. We had to halt it first so we could dump it.
Yeah.
And then we dumped the whole thing. And so I'm using XXD to show you guys here. So there's the ASCII on this side, and then we have the hex values here. And you can see a lot going on here. So.
But he has that, and then he needs a way to interface his computer to the target board that he's trying to hack the firmware on or control the hardware. So that's what that little Raspberry Pi is for, and that allows him to actually connect over USB from his computer to the Raspberry Pi, and he's got just jumper wires that are connecting over to the other board through that SWD wiring, it's going to be a serial in and out connection, which is for your data. There's a clock signal and then a ground signal. So there's 3 wires that you have to hook up. And once those are hooked up, he can use that OpenOCD software to take control of the hardware.
And there's other devices like this one here. This is a Bus Pirate 6. Bus Pirate's been an awesome device that I've used throughout the years to hack on badges and other things. This PiFex is new to me, but I really like it. It's a little bit of a learning curve. Honestly, a lot of the stuff on the Bus Pirate was a little easier than using like OpenOCD, for instance.
Yeah, that's probably faster though.
Yeah, way faster.
Yeah.
And single wire debug is faster than JTAG too, is what I've noticed. So slightly on the same boards is kind of interesting. The way it was described to me, and you can probably speak to this better than I can, but like you have your debug port that you're connecting to, and then within the MCU there's access points access ports for each debug within that system in the MCU. So that's kind of the architecture for the ARM debug interface, and then this is an example of those debug connectors. So this is JTAG here, which is a standard that you'll see a lot out there. I just didn't demo it for sake of time in this class. I want to demo the
They're
newer stuff.
effectively about the same.
Yeah.
It's just more wires.
Literally more wires. You see NC here and NC here. It's
Yeah,
minus-
the only ones that really matter are
minus 2 wires.
those top 2 on the right. That's
Yeah.
DIO is your data in and out, and then the SWD CLK is your clock signal.
Yeah. And then the old one, it's 4 wire plus here.
Is it, what you mean, you first hacking the network and then to...
Nope, this is
No?
just device. This is
Just the
him just
device.
hacking a piece of hardware over here.
Yeah. And forget about the network here. Yeah.
So,
in the network, you have to know the laptop hardware, that kind.
Well, you can hack the device's network if the device is a switch or
Yeah,
something
this is
like
actually
that.
like
That's another tier.
there was actually an old trick that I used to do with that, which was
What's that?
because I got good.
What was happening here, let's say you have a modem, an old modem that is not working like you want to, but you can get more out of it. So you tear it apart and you use these methods to improve it to what you want that modem to do.
Okay.
That's one example.
Yeah.
Real.
Can you, I'm sorry.
Yeah.
All right, so you did the dump of the firmware.
Yeah.
Okay. Is there maybe a convenient plug-in for a disassembler on that?
So that's what I was going to say. Is
Oh, I'm sorry.
What you can do next with that
Okay.
is I recommend Hydra. If you have access to IDA Pro, that's a great option too. I'm trying to get to the point where I'm combining some of my hardware projects with my reversing projects, so it's kind of cool. But yeah, anyway, that's kind of the next step, and go from there. And then
So, and I'll add this in here because if you have, if you're doing an ARM-based firmware, ARM came up with a CM SIS SVD, which is files that describe the hardware. And somebody created something that's called the SVD loader, which allows you to take those SVD files that explain that hardware and load it into Ghidra, and Ghidra now understands the memory mapping and the pinout of that chip. So when the firmware is trying, because the way that it works with these pins is it just reads and writes to memory and sets registers in memory. That's already mapped in Behedra, so it's gonna make a lot more sense when you're looking at your phone.
Okay.
And then,
Hey,
you know,
I know these boys.
We're,
Right.
we're
Yeah,
seriously,
that's his office.
seriously out of time.
yeah, we're way out of time, so I'm gonna end it
No,
here.
no,
But thank you
we
guys
still
so
got
much.
5.
Oh,
Go on.
Well, I can start packing up. I guess all questions are answered.
I do
Right?
wanna see those.
Questions?
Yeah.
Everybody? Answer questions for 5 minutes.
Yeah, please come up and check stuff out before I have to pack it all up. Yeah.